And we're on the air. Hello, friends. Welcome to Code Mentor Office Hours. We have another exciting episode for today. I decided I'm going to start calling them episodes because they're feeling kind of episodic. But for if it's your first time joining, welcome. We are amidst a series of office hours that are kind of part of this JavaScript framework series we're doing. So meeting with all sorts of experts around all things JavaScript. And today we're really excited to have Rebecca Murphey with us. So I'm going to give Rebecca brief introduction, and then we're going to kick it over to her for a presentation. But if you're new to this, please feel free to use the group chat if you're in the live room with us. If you're watching the live broadcast, not in this room, there's a Q&A app you can use, and feel free to throw questions in there, and I'll be sort of collecting them as we go, and we'll hit as many as we can. So without further ado, Rebecca Murphey is a software engineer over at Bazaarvoice, where she leads a team that shepherds third-party JavaScript application development for products with a reach of hundreds of millions of visitors across billions of page views. She authored the learning site jQuery Fundamentals, contributed to the jQuery Cookbook from O'Reilly Media, served as technical reviewer for David Herman's Effective JavaScript, and created the TXJS conference. She studied journalism at Lehigh in Bethlehem, PA, and during her 5 semesters she attended, she created the college newspaper's first online presence. She's joining us today from sunny Austin and is going to walk us through client-side JS apps and having them accurately report their performance. So everyone on mute, very happily welcome Rebecca Murphey.
Hey, thank you for having me. I only do one of these online things like a couple times a year, so I'm a little rusty at how this goes. I have a presentation that I put together, so I'm going to share that. But I also just wanted to say, since this is live and kind of small, if you have questions while I'm talking, we can turn this into more of a conversation as well. If you want to type those questions into chat, I will. Actually, I won't be able to watch chat because I'll have to have my presenter notes up. So I'll try and flip over every now and then and peek at chat and see what's going on there. But yeah, definitely looking forward to the conversation aspect of this. The talk is only maybe 30 minutes long, so that should leave a good amount of time for questions. Mark, I'm going to just have you verify that you're seeing my screen.
All good.
All good. Awesome. All right. So this talk is called Apps That Talk Back, and the idea being that like we put this code out in the world, and we need to know how it's doing. And when you are developing, a traditional server-side application, you own the hardware where that application is running. And so it's very easy for you to just, like, at worst, just log into the box where the code is running and view the logs. Like, you can actually do that. With a client-side JavaScript application, it's kind of a different scenario, right? Like, in our case, our application is running on like literally hundreds of millions of boxes. Like, it's kind of mind-boggling. But our application runs, we see hundreds of millions of page views every month, and so our application is running on every one of those page views. It ran on somebody else's computer. We can't log into their computer and see if the application had any errors or whatnot. So the application that I'm talking about today is the display for the ratings and reviews software that we develop at Bazaarvoice. There's actually a few different display applications, and it's complicated, but I'm going to talk about one of the display applications. It's an application we call Firebird inside of Bazaarvoice. And at Bazaarvoice, we work on software for collecting and displaying ratings and reviews, and it's software that is on some pretty big websites that you have definitely heard of. I am going to keep it simple and not name names, but chances are if you saw stars and reviews on the internet and it wasn't on Amazon or eBay, there's a pretty decent chance that those were Bazaarvoice stars. And we're definitely on some very major retailers and brands. So the cool thing about this is that this thing that we do, it has a direct impact on our customers' ability to make money. This is a quote from Deloitte leading up to the holiday shopping season last year, saying that people going online to research products basically would influence half of retail sales stores. So it's not just people who are buying things online, but also people who are doing research online, and I say people, I'm talking about you, I'm talking about me, like we all do this, right? You go research online, maybe you go buy in store, maybe you buy online, but the content that you see online about a product is extremely influential. A simplification of that in Bazaarvoice land is that stars mean money. It turns out that reviews, even bad ones, are a super positive influence on purchasing decisions. Just the fact that a product has reviews, even if they're like, meh, that gives consumers more confidence in a product than if there are no reviews at all. So I bring all this up to say, I'm not trying to sell you on Bazaarvoice or sell you on ratings and reviews, but just to explain that this thing that I work on impacts the bottom line of our customers. It's not just some vanity software that they're running. I don't even know what vanity software they might run. It's not just some vanity software that they're running. It's actual. It affects their bottom line, and so they get it on their page by just putting a few lines of JavaScript into their site. Like seriously, they just put a script tag in like 5 lines of code that really you could collapse down to 1 line. Just make it 5 lines to make it readable. They put this tiny bit of code on every product page, and they get the interface that I just showed you, plus this little bit, this little summary that says like, this is a really great pair of jeans. 9 people say so, and you too can write a review. What this means, though, like the nature of third-party JavaScript and the nature of the application that we work on, is that our app needs to work on any site, like anywhere, any kind of site that our customers make, our app needs to work there. It might be a site running PHP or .NET or Node or Ruby or Java. We can't care. It might be using the latest, greatest front-end technology, or it might be using a version of the prototype library that came out in 2008. Or it might be using prototype and Dojo and YUI and 2 different versions of jQuery. No matter what, our code has to just work. And so, needless to say, sometimes it doesn't work. Sometimes things go wrong, and suddenly someone shopping for a pair of jeans is not seeing that these are actually a really great pair of jeans, and nine people say so. And the reasons that this happens are really varied. Sometimes we screw up. We've made a mistake in our code, and now it doesn't work well with a particular customer site. Sometimes the customer makes a mistake. A customer might get that little bit of integration code wrong, even though it's 5 lines. Like, they might screw up and not provide a product ID, and we can't actually show stars if we don't know what product to show stars for. Sometimes customers do things that we just completely didn't expect, and I have a whole other talk about that called Ain't No Party Like a Third-Party JavaScript Party, that just talks about the crazy things that customers do that we just didn't anticipate, like a customer who had 2 body tags on their page, or a customer who redefined array prototype index of in such a way that it didn't return -1 when the element wasn't found. These are the kinds of things that sometimes happen, and next thing you know, there aren't stars on the page. And like I said, stars are money. When there aren't stars, our customers make less money, and this makes our customers sad. So there are, and this number that I have in here in my notes is probably old. When I first wrote this, there were more than 1,200 retailers and brands using this particular application. There's actually a lot more retailers and brands who use Bazaarvoice in general. But there's more than 1,200 retailers and brands using this app, and last month we saw, or I'm sorry, in December, we saw hundreds of millions of page views across tens of thousands of unique visitors. Actually, probably way more than tens of thousands of uniques, like probably way more. I throw out all these big numbers that I can't even keep track of because we literally cannot check every page that our app is going to be on. This is not an app that runs on a domain that we control, and so we can go run it through its paces on that domain. This app runs anywhere and everywhere, and the environment in which it runs can change without us doing anything. So we can't actually test it for all the possible scenarios that it's going to execute in. And this is what brings me to the concept of apps that talk back. If we can't know ahead of time that our app will always work in all the scenarios, we need a way to know quickly that it is not working in some scenario. And this was kind of the challenge that I set out for myself going into the last holiday season, was to figure out how we could get a lot more visibility into how our app was doing out in the world, as far as getting visibility into errors, getting visibility into performance, getting visibility into when things did go wrong, being able to rapidly figure out what was going wrong. And also putting up some safety nets or some guardrails so that we would be less likely to make things go wrong as we were doing development. So yeah, this was kind of my hit list last year, and I actually developed this hit list before this time last year, and it's been really interesting to see the progress that we've made and the things that are still kind of on my to-do list. But let's talk about some of these things, and how what we did, what it means, how we did it. And I want to say before I get into it, some of this is hard, some of this is trivial, a lot of it is somewhere in between. A lot of it is really hard to get right the first time. A lot of this I was able to get right only because we had done it wrong and we gathered bad data, and I was able to see, by looking at the bad data, I was able to realize what I did want to gather, but it would have been really hard to know that from the start. So hopefully this will give you some ideas about things to think about. This is not a how-to by any means, but hopefully it'll give you some things to think about and some ideas to think about and some questions to ask of your own app when you go back to the office. So the first and most simple thing that we could do and that you can do is just to get basic monitoring in place to know, like, is my app even there, right? And so we serve our application from a few different domains. There's the API that provides the data to us. There's also a few different hosts that provide static resources for us, both via HTTP and HTTPS. And then we also have a server that we maintain where customers can configure their application and see what their application will look like as they make changes. So they might change their stars from yellow to red, and we have a server that shows in pretty close to real time what those things will look like. And so the very first and simplest thing that we could do, we use Pingdom, but there are certainly other services out there. We use Pingdom to just know, is it on? And with Pingdom, you just set up some URLs, and Pingdom goes and visits those URLs on a super regular basis, and makes a note of the response time, and even more important than the response time, just is it up or not? And this is cool because if your system goes down. It's not so cool because really we're serving static resources from S3 with Akamai sitting in front. Akamai is a CDN sitting in front of S3. If one of these hosts stops responding, there's probably very little we can actually do about it, right? Like, it's probably S3 or Akamai is down and the entire internet is sad. So this is like nice to know, but not super useful. It doesn't really tell you a whole lot. And because of how Pingdom works, even the response times, Pingdom pings from all over the world, and it's really hard to set up any reasonable alerting on the response time using Pingdom data. We tried it and we got some false alerts at 2 in the morning and everybody was angry, and so we just decided to turn those off. So we do have it set up so we do get an alert if the internet is down. Like I said, there's not a whole lot that we can do about it, but it's one of the most basic things that you could do, and this may be more relevant for your service than it is for ours, because again, our service is just S3 Akamai static files, nothing super interesting there. Knowing whether it's up or down doesn't tell us a lot, but it might tell you a lot, and so this is a simple thing that you can do. We also monitor the services that actually make our application work. So I mentioned the API that serves us data, and so even though we don't own that service, there's another team that owns that service. We want to know if it's doing badly. And even if it's maybe trending badly but hasn't crossed the red line, we want to know about that. And so we've set up monitors just for these basic things for response time. Again, it's hard to do too much with response time because variability is expected. And even if you get a crazy spike like you can see in the top graph, it's not meaningful unless it stays high. So you can set up Datadog, these graphs and monitoring we're doing with Pingdom and then Datadog. You can set up Datadog to alert when a metric is above a certain threshold for a certain period of time, and that's kind of what we settled on. But even then, we were not getting a ton of value out of that. You might, though, so I wanted to talk about this because this might be a really applicable first thing to do for the product or service that you're working on. Datadog is great. I don't even want to think about how much we pay for it because we send so much data to it. But Datadog is a great service if you're not aware of it. It lets you do some not like super complex alerts, but it lets you, if you have a metric that you want to know when that metric goes out of bounds, then Datadog is your friend. Super helpful for that. So that talks about like the whole internet is down or the API is down. And in both cases, those are things that aren't really within this team's control. We can alert other people that this is happening, but there's not a lot we can do about them. But what about when there just aren't stars on the page? Like, can we get an alert when that happens? Or how can we get an alert when that happens? If the stars aren't on the page because the API is down, we've already got that case covered. But what if the stars aren't on the page because, let's say, the customer didn't define a product ID, and so they're trying to display, they're asking for stars, but they aren't saying what they want stars for. So from the pretty early days of the app, we had been sending error reports to our internal analytics tool via an BV Tracker, which is just a class that we wrote that talks to our internal analytics tool. But you could talk to Google Analytics as well and just send it events. It's kind of the same thing. So we've been doing this from the really early days of the app. When there was an error, we would send an error. Cool, it's great. But I was talking about how a lot of this I didn't know until I saw bad data. This is an example of bad data. It turns out that when you're getting, 1 million of these errors, it doesn't tell you a whole lot. And unless you know that like this particular string is really important, it's really hard to separate the important errors from the unimportant errors. If everything's just an error, it's really hard to know like this is worth waking someone up for, and this is one that we can just deal with in the morning. So this was a big change. It was like a big value, but not a hard change that we made, was to actually send errors that have information in them, not just a string. This is like brutally obvious, but we didn't do it the first time around. So The second time around, we created errors that actually had more value to us as far as trying to understand the state of our application. The biggest thing that we did is we kind of diminished the importance of that message, no product ID is defined, and instead classified this error to say, if no product ID is defined, I know that this is an implementation error. This is an error by the customer. This is not an error in our code. Like, if this particular error condition has been hit, it's because a customer made a mistake in implementation, not because our code is broken and we need to wake people up. And so we came up with kind of a set of categories for the kinds of errors that we were seeing. We went through our code and found all the places where we were sending errors, did a little bit of assessment of what those errors were, and said all these errors fall under one of these buckets. And based on these buckets, I can now make a rational decision about how to alert on these. I'm not going to alert on a request timeout unless there's a lot of them. I'm not going to wake up a developer over an implementation error, but if there are a lot of them, I'm going to make sure that customer support can go work with that customer to fix them. If there's a third-party service error, good to know about. Not a whole lot we can do about it. So again, let's not wake anyone up. So the goal here was to have context-appropriate alerting for different error types. Like I said, certain errors are PagerDuty worthy, but lots of errors aren't. We still want to know about them, but we don't need to wake anyone up. So once we had this, we worked with our analytics team to be able to get access to all the data that we were sending them. We were able to use Kibana, which is what's powering this. Kibana is just a UI around Elasticsearch. We were able to dump all that data into Elasticsearch and get a user interface using Kibana with very little setup that would let us see those errors in nearly real time and drill down into them so that we could see what was actually happening. And then we were able to create dashboards that were isolated just to those errors that we considered really critical, and to create other dashboards for errors that were implementation errors that were important but not necessary to wake people up about. So this is a screenshot of like a bad thing that happened one day to a customer where the customer had implemented the application in a way that was using way more API requests than it should have. And so their API requests they were being denied, they were being rate limited, basically. We were able to, because we had set up all this and done all this work and worked with the analytics team to get the data into Elasticsearch, we were able to see this happen in nearly real time, get an alert about it, because the number of critical errors exceeded a certain threshold. And then we were actually able to call the customer and tell the customer that they had a problem. The customer was not the first one to experience the fact that they had a problem. So it wasn't the customer calling us and saying there are no stars, it was us calling the customer and saying there are no stars and here's how to fix it because it's an error that you have made on your end. This was like, I remember in the first few weeks after we got the system set up, like the amount of knowledge that we had suddenly about things going wrong was just amazing, and it was especially amazing because we were detecting things before customers did, and that put us in the position of being proactive instead of reactive, and it was really cool. The other thing that we did was we developed a web app that lets people outside of our team get visibility into those errors on a per customer basis. And so this is a report that you can access for a customer. You see I blacked out the customer name, but this is a report that you can access for a customer that gives you a summary of the errors for that customer in the last 24 hours. And so if a customer is experiencing issues, let's say you're in support and you get a ticket from a customer saying, I don't have stars, you can go look at this page and quickly see like, oh, well, maybe because you have failed to provide a product ID 358,000 times. That might be why you don't have stars. So this is a cool thing too, that it was able to shift some of that initial investigation work off of the team, the development team, and over to support. So yeah. Another thing that we have done around monitoring the state of our app is tracking performance things. So the way our application works is that any customer can request a new build of their app at any time. So if they change, turn a feature on and off, or change the color of their stars, or otherwise make a configuration change, we actually generate a new set of static resources that reflect that change. Again, this is a thing that is hard to test all possible cases because there's a lot of features that they can turn off and there's a lot of settings that they can set. And so what we do is we send data, again, to Datadog every single time that we do a build. And we're able to see what our build sizes are, what our build times are, and how many builds are waiting in the queue. And we've actually set some, basically our builds are run by a grunt task, and we just put some instrumentation in that grunt task at key moments where it just sends an event to Datadog saying, hey, I just got done, and the JavaScript that I built in gzipped was 250K. And Datadog's like, cool, got it. And so we send this every single time we do a build for every single file that we create. And we also send information about how long our builds are taking, and like I said, how many builds are waiting to be completed. And using this, we're able to see if see if anything is happening that we don't expect to be happening. So BV Primary is kind of our core application. It's the first yellow box on this screenshot. We're uncomfortable with the size of that right now, and we want it to be less, but we definitely don't want it to get bigger. And so we've set up an alert, again, in Datadog to tell us if this exceeds a certain threshold, you need to let us know. Like, we need to do something about it. Ditto for these other files. BV API.js is the very first file that we load. It's called the Scout file, and it needs to be less than 14.5K, or else it will take too many round trips to download it. So we want to make sure that it can be downloaded in one round trip. The limit for that is 14.5K, and so we have an alert set up. If we start to get close to that 14.5K limit on that file, we will get PagerDuty will yell at us, and we will need to go figure out what to do about that. So it'd be really cool to get this sort of instrumentation going in the in our development process, right? Like as you push a new branch, have it do a build and see what size it is. But like I said, the problem is build sizes can vary wildly based on the configuration options that people have turned on. You can see even on this graph, you can see there's pretty big movement. So we certainly should get that instrumentation in place for individual pull requests, but in the meantime, and even after we do that, this is still really valuable because it lets us see what's happening in reality, not just in our development environment. And those sorts of concerns are really unique to third-party JavaScript, and not, it may be that if your application is one that doesn't run on a bunch of different sites with a bunch of different configurations, a much smarter place to do this sort of monitoring is at the pull request level, not at the actual build level, because you may only do one build per deployment, and in that case, a build is a build is a build, and the numbers are always going to be the same. If you are building, we build literally thousands of these on a busy day, and those numbers can be all over the map. We need to be able to see what's happening in the real world. So another thing that we've done is to instrument key moments in the application itself. So when are all of the resources for the application loaded? When do we actually show up on the page? Like when are we finally visible on the page? What's the time between when all the resources are loaded and when we show up on the page? So my teammate Lon Ingram did a bunch of work around this using the window.performance API or performance timing API, and was able to instrument just a bunch of really interesting moments in the application. And then just like we were sending error data to our analytics tool, we sent diagnostic data to our analytics tool. And the analytics team was able to get that data back to us in Elasticsearch. We put Kibana on top of that Elasticsearch, and now we're able to get great visualizations of the real world experience of our users. This is not data running, this is not running on like a web page test instance or anything. This is what we're actually seeing in the world. And the nice thing is we can filter this by user agent and by operating system and all sorts of different things. So if we want to drill down and see like what is the mobile experience, we can see that. We can separate out the mobile experience from the desktop experience, or we can separate out the IE8 experience from the Chrome experience. And this, again, not particularly hard. Probably the hardest, well, there's two hard parts. One is figuring out where are those key moments in your application. The other one, the hard problem for us, is that for us, it's just an ocean of data. There's, 7 lines on this screen. That means we're sending at least 7 diagnostic events for every page view. And I said before that we're talking about hundreds of millions of page views every month. So we're sending hundreds of millions times 7 events, just diagnostic events, and then we need to get those back out. So at the scale that we're operating at, one of the hard problems here is just the sheer magnitude of the data. If you're operating at a smaller scale, this is a way easier problem, a way easier problem. So I kind of leave that as an exercise to the reader, because I'm not a big data person. I can't tell you how to solve the problem of that quantity of data, but it's very possible you don't have to solve that problem. You could. There's a couple different ways you could handle it. One is to basically have a dial that you can turn to say what percentage of page views are going to send these events at all. Or it may be that your audience size is more reasonable and you can just send these for all page views, and you can send them to Google Analytics or something and get your data out of there. Another thing that we have really emphasized, and this is kind of still in the apps that talk back topic. Another thing that we've really emphasized is making it really easy when we find out that there is a problem to rapidly investigate that problem. Because again, stars are money, and we want to minimize the amount of time that there are not stars. So we put some tooling in place that lets us pretty quickly, this screenshot is probably meaningless to you, but it's super meaningful to me. What the screenshot is tooling that lets us rapidly recreate a scenario. So if we know the customer and we know they're having a problem in production, and we know that they are we know the customer, we know they're having a problem in production, we can go to this page and see, oh, for this customer in production for the site called the Danger Zone, there's no Firebird actually installed. Well, no wonder they're having a problem. And now we can go investigate that. So this gave us visibility into some kind of common mistakes. We could quickly identify common mistakes, but we could also, you see these prod/local links. Those are implementations, like development implementations of whatever the customer has in production, so that we can rapidly, see we can experience the problem that they're having on our own machine with code that we can go and manipulate rather than having to try and manipulate production code. So those were just creating tools that automated common processes, common debugging processes, common pieces of information that you wanted when you were debugging has really gone a long way for helping us, once we discover an error, doing something about it. And this example here is very specific to our application, so it's hard for me to show this page and say like you should do this too. Really, I would simplify it to what I just said, though, that figure out what pieces of information you always want when you are debugging a problem, and make a tool that gives them to you so you don't have to go dig them up. For us, it's this information. For you, it might be different information, but having at your fingertips access to common debugging information is huge and not actually that hard, because you do this all the time. Just put it in a tool and give yourself easy access to it. Another thing that we did is we had an issue with a customer in production. These are feedback buttons in the user interface, and when you click on them, they should increment, right? If you say yes, it was helpful, then the number should go up to 2. And we had an issue where our feedback buttons weren't working for the customer and in production, and we couldn't figure out why. So the first thing we do is we open up our console, right? But when we open up our console, there's nothing there, and that's on purpose. We don't want our application cluttering the console with noise. So we actually wrap all of our errors in try-catch, and we don't let them go to the console, because customers get grumpy when they're in the console, when we're in the console. So we're intentionally silent here, and that really is a bummer when you wish you knew what was going on. So we did a really simple thing, and we made it, we added a couple lines of code to our application so that if this cookie is set, then suddenly we're making all kinds of noise in the console, including we're no longer catching errors, but we're also spitting out a lot of information about the life cycle of the application, so that you can very quickly see, like, oh, this error happened when we were rendering the top view for the BBQA container. I know exactly where to go look now and figure out what's happening. So suddenly it was really easy to see what was going on and to see errors without having to like break uncaught exceptions, which can really suck because jQuery, for example, has all kinds of caught exceptions in it. You're catching exceptions is a good development pattern, but it can be a pain when you're trying to debug. So that was a big benefit to us as far as being able to do production debugging. The other thing, of course, and I'm embarrassed to say we haven't done it yet, the other thing to enable production debugging is source maps. Make them, use them. I can't explain why we haven't yet, but source maps let you see the unminified, fully commented version of your code at a click of a button, and be able to debug using that rather than using the minified and obfuscated code. We also use Charles Proxy a lot to proxy the production files to something on our local machine, but really source maps would be a great tool for us to do that as well. Wrapping up here is safety nets, guardrails, whatever you want to call them. We didn't have a lot of these in place earlier, and it was really easy to do stupid things. For example, to leak a global variable, and that's bad all the time, but it's really, really bad for third-party JavaScript apps because you might be stomping on someone else's global. So some really simple things that you can do to get your app to tell you it's in a good state on your own computer, not even out in the wild, is to set up Git hooks. The important thing is to make sure that whatever hooks you set up are low friction, so you don't want to have like a 5-minute process that runs every time you commit. Maybe you want to save that process for just pre-push, and maybe you should figure out why it's 5 minutes and try and get it down to something less. So yeah, Git hooks are a great way to test code on your computer. We mostly save these for running the unit tests, and as long as they're fast, and also running code quality tools like JSHint and JSCS. Another thing that we do, though, is we have continuous integration set up so that we can test. We can test. We can run tests that take longer only on pull requests. So once a pull request exists, the continuous integration server kicks off and starts running our tests, and a pull request turns red or green. Someone is messaging me, but I can't actually see it until I get out of the presentation. So I'm just gonna flip to the window for a second and see if, oh my gosh, there are so many questions.
It's cool, Rebecca. I've been keeping track of them, so you can finish up, and then we'll hit some questions.
Awesome. Well, I'm almost done here, and then we'll still have a good 20 minutes left for questions. So let me just wrap up here. I'm gonna skip over some parts here. This is going longer than it did last time. I don't know why. Just a couple more things in the guardrails topic. Assertions in your code are lifesavers. You've probably seen errors like this from your code, and you're like, ugh, now I have to go figure out what the heck, like, what is that even? And so we've gone and put assertions in our code around key moments where something might go wrong. And now we get pretty error messages like this that actually tell us, like, what was undefined rather than just getting a useless message like that. So that's a really easy thing to add to your application as well. Anytime that you have an argument that is required, in JavaScript there's no way to say that, but you can say it with an assertion in your code to say, like, if I don't have this .component ID right now, let's just throw an error. Nothing's going to go well from here on out. This is especially valuable in async code, because often if you don't check up front that you have what you need, you might not see an error until some later turn of the event loop, and that can be really hard to debug. So putting assertions in your code is another great way for your app to kind of talk back to you during development, and do it in a useful way, not do it like this. The rest is blah blah. That's about all I've got. Check me out on the internet, and I can take questions.
Awesome. Thank you so much, Rebecca. Actually, before we hit any questions, I should have asked you this beforehand, but are you going to be able to provide the keynote at all, the slides to people?
Yeah, absolutely. I will. They're probably actually already on my speaker deck because I gave very close to this presentation at Future of Web Apps. But I will make sure that they are, and I'll put them out there. I'll
Awesome.
get them to you in an email or something.
Cool. Yeah, I'll send everyone who's RSVP'd an email with some links afterwards. So just verifying that. So so Shaitan asked a good question. What is the backend for Kibana? Is there a backend developed to populate Kibana with errors and keep on polling in real time?
Yeah. So Kibana has nothing to do with the real-time aspect of it or the population of it. Kibana is really just a user interface for looking at data that is in Elasticsearch. So Elasticsearch is a database, and Kibana is just a user interface to that database. It's like not unlike PHP-MyAdmin or something like that. It's really, except it doesn't let you do writes. It just like lets you see the data in Elasticsearch. And so it's up to you to populate the Elasticsearch database. That is an exercise for the reader if you are using Kibana to populate that database in the manner that you want. This is not hard. This is not a particularly hard problem. Doing it in real time with a lot of data is hard. Thankfully, we have a big data team that figures out how to stream that. They stream us like 5% of the actual data that's coming in. They expose a stream, we read that stream and stick stuff in Elasticsearch. Kibana, I think, is largely just an Angular app with probably an extremely lightweight backend. I don't even know what the backend is written in, but the front end is just an Angular app, and really, it's a very lightweight server-side app. Really, the value in Kibana is the front end, and it's all just talking to an Elasticsearch database that is up to you to populate. And you could populate it with real-time data. You could populate it with yesterday's data. Populating it with real-time data is a service that you would have to implement. Luckily, we have. It's kind of beyond the scope of this talk because I don't know how we have done that. But it's a the service we have created is very much like Google Analytics in that it you send it events, and those events get written to a log, and then that log gets processed and turned into data. And then we use that data to populate Elasticsearch.
Awesome. Can you explain Firebird a little bit more?
Yeah, so Firebird is a third-party JavaScript application. And when I say that, what I mean is that customers don't do any server-side integration to make it work. They literally just put a script tag and a little bit of JavaScript on their page in order to make it work. And so customers make a div in their HTML, they put the script tag, they put the configuration information, and then Firebird is an app that responds to that by creating a rich user interface, like that user interface that I showed at the very beginning with the stars and the reviews and the sliders and stuff. That user interface is created entirely client-side by Firebird, and Firebird does that by asking, given a product ID, Firebird asks the API for the data associated with that product ID, and then uses that data to generate client-side all the HTML and interactivity that you saw on that screen. I don't know if that answers that question or not.
No, that's great. I mean, actually, that goes well into my next question. By the way, if anyone has any additional questions, throw them into the chat. I'm going to go to some that were emailed in. But on the topic of third-party stuff, I thought this was an interesting question. Someone was curious, is it possible to build some of these data notification functions that you showed into their own code, or is integrating with multiple third-party tools really the only way to do it efficiently?
So I mean, you can build all of this stuff yourself, and we have built the collection aspect ourselves, and it's open for debate whether even that was a good idea, or should we be paying someone else to do that collection for us. So there's three different pieces, maybe four different pieces. Probably I'll think of six by the time I'm done here. But the first piece is the application that is generating the events. That you wrote yourself, and you need to write the generation of those events yourself. Although there are services even then, like I think New Relic has something, and there's another one that's escaping me right now. There are even third-party services that you can use client-side to actually generate the events. To whenever your application throws an exception, there are tools that will notice that and send an event to you. Send an event somewhere. I think it might be Track.js. Thank you, Oliver. And there's maybe even another one anyway. Anyway, there are tools and services that will do that for you. So there's the place where you are generating the events. There's the thing that collects the events. This could be Google Analytics. It could be something you roll your own. But there's a thing that collects the events. And then there is the getting those collected events, getting the subset that you care about into a tool where you can view them. Because the collector, in our case, because it's dealing with so much data, is really just like writing it really fast to a file, and then every couple of minutes that file gets processed by some other tool, right? That file gets processed and turned into and sent to Redshift. And then if we want data out of Redshift, and I'm probably getting some of this wrong, then if we want data out of Redshift so that we can play with it with a tool like Kibana, we have to, that's a whole other thing, to get the data out of the like massive data store into a data store that just has the pieces we want. Like, I don't care about events from other applications, I just care about my events. So getting those in a way that we can view them is a thing. Then there's also things like the graphing of it all. You can totally build your own and don't pay Datadog money. Like, sure, it's just another engineering problem. You could totally build your own thing that would actually show you that data over, show you time series of the data and whatnot. And you could totally build your own alerting system so that when the time series exceeded or fell below some threshold, you would make some noise about it. All of those are things that you could build yourself. For us, it has just made sense to use stuff that's off the shelf rather than to try and hire people to do it for us, because it's way easier to pay money to services than to hire people.
Totally, not reinventing the wheel.
Yeah.
Cool. So slightly broader question. A couple people emailed in, I think, that are probably on an earlier phase of this journey than yourself. How do I go about learning client-side JavaScript? What frameworks should I invest my time on if I'm sort of getting started here?
Sure. So I have a couple of posts on my blog about this. One is one that I wrote 3 years ago called A Baseline for Front-End Developers, and one I wrote 2 days ago that is also called A Baseline for Front-End Developers 2015. So those are a couple of good starting points that just sort of spell out the lay of the land. And one is from 2012. That's the one to start with because things were simpler then. And make sure you have those topics covered before you move on to the one from 2015. They don't tell you everything you need to know. They just tell you everything you need to know, and then it's up to you to go know them. But they don't tell it to you. They just kind of are a checklist of things that you might want to look into, learn about, play with, try, and understand. So those are, I wrote them, so I'm biased, but I think those are a couple of pretty good resources for that. As far as frameworks, all of them. Like, there's no right answer, and the best thing you can do is understand more than one. Do not fall into the trap of being a loyalist to one. And if I interview you and I ask you what your favorite framework is, and you tell me, the next thing I'm going to ask you is everything that's wrong with it. Like, I expect you to be able to tell me all of its shortcomings. If it's your favorite, you better know what's wrong with it, what could be better about it, what's broken. So yeah, Backbone is a nice, simple framework to learn and use. It will only take you so far, and then you'll learn about Ember, and then you'll be like, wow, Backbone is really stupid, except it's not for a certain set of problems. And then you'll learn about React, and you'll be like, wow, Ember's really stupid, except it's not. Like, it's not even for a certain set of problems. It's like, it's a very viable framework that's under active and amazing development. And so is React. And they take different approaches, but they're actually sharing a lot of things between them, and like sharing a lot of ideas between them, and it's exciting and great, and you should use both and become familiar with both, and do not fall into the trap of, like, I am an Angular guy. Like, whatever. That's my rant.
Don't choose your religion.
Yeah, don't choose a religion. Just build things. Build things. That's how you get acquainted with this, is just to build things. You can read all the books you want, and there's some great ones. Eloquent JavaScript, I think, is fantastic. But really, the way that you get good at this is by building things.
Totally. Kirkus, I was curious, can you list the stack of services that your organization uses again?
Oh my God.
I know it's a lot of names.
I mean, it's... So for the particular services I've talked about today include, but are not limited to, PagerDuty for actually sending alerts and managing on-call schedules, and I get a call from PagerDuty. I'm holding it in my hand. I get a call from PagerDuty on my phone when something goes wrong. So that's one service that we use. Datadog is another service that we use. They collect metrics and provide alerting around those metrics. You don't want to send Datadog page view data, for example. That's not what they're good at. They're good more at time series data. So like at this moment in time, this value was 2. Datadog is really good at that kind of thing. It's not good at counting at all. And so it's much better at saying like, what was the value of this thing at this moment? So we on the big data side of things, I honestly don't even begin to know how all that works. I do know that there's a really great blog post on the Bazaarvoice developer blog about how it all works. So if you're interested in learning more about the big data aspect of this, check out blog.developervoice.com. Let me see if I just made that up. I think maybe that was totally it. So check out blog.developer.bazaarvoice.com. There's some posts on there about how we solve these big data problems. And that is definitely not my area of expertise. We are the number of technologies that are in play at Bazaarvoice is enormous, and so that would take a whole other show. And I'm definitely not the expert on that, but those are some of the ones that I talked about today.
Cool, that was helpful, thank you. I just typed some of them out too. So we've time for probably just 1 or 2 more. If anyone has any other questions, throw them in. What other services do you think are handling large client-side JavaScript apps really well that we could look everyone else could look to it as examples beyond some of the stuff that you showed?
When you say handling really well, what do you mean by that?
I guess ones that you admire, how you can tell it's configured and how it's working, at least as an end user.
Yeah, I mean, definitely the stuff that Facebook is doing is amazing. They're certainly dealing with far larger scale problems than we are, and I really admire them. And also Netflix, both of them are really good at running tests in production. They try things in production and get real data back about what they're trying. That's something that I aspire to doing a lot more. Right now, pretty much everyone gets the same, they're all pulling from the same base, and there aren't, 2 different code paths that 2 different customers might get for a given feature. But at Netflix, there's totally 2 different code paths that 2 different people might get for the exact same feature. And I really admire that they have worked out how to do that at scale and gather meaningful data about that at scale. That's a big deal, and that's a neat thing. Certainly, all the big folks. Discuss is another. I really look to them in the third-party JavaScript land because they're dealing with a lot of the same problems that we are, and 2 guys who used to work for Discuss literally wrote the book about third-party JavaScript. If that's an interesting topic to you, the book is called Third-Party JavaScript, and it's the manual. It is the manual for how to do this thing that we do, and it's pretty neat.
Awesome. Yeah, we actually have a couple sessions coming up, I think, in the next month with a couple developers from Netflix talking about that exact issue. So yeah. Awesome. Well, Rebecca, thank you so much for your time. For everyone who's attending, this will be on the Code Mentor YouTube channel, so please feel free to go back and review a lot of what Rebecca discussed. We'll also send out links to her slides, and people should definitely check her out on Twitter and her blog. Keep track of what's going on, and thank you everyone so much for attending. We have a lot more great JavaScript sessions coming up, so check that out. And obviously, Code Mentor is at your convenience if you ever have any JavaScript issues that we can help out with. With that, I'll say thank you so much. Good afternoon, good evening, good morning, wherever in the world you are, and thanks so much.
Thanks a lot, Mark.
All right.